А больше она всегда там, да? Больше не открывается, да? Ладно, хорошо. Спасибо. Dear students of second division, good afternoon. Today we should discuss the most important question, water. Water is one of the most important elements of surrounding environment necessary for mankind, animals and plants. All water sources on the Earth are united under the name hydrosphere. Hydrosphere is a totality of water objects, including oceans, seas, rivers, lakes, water reservoirs, underground water, ice houses, snowy cover, and water of atmosphere. Hydrosphere regulates climate, provides household and industrial activity of man, participated in composition of all beings. In the human organism, water plays a role of structural component, solvent and transmitter of nutritive substances, participates in biochemical processes and heat exchange. The main problems of hygiene are conditions of water supply of population and water quality and ways of its improvement. Now we should discuss physical and chemical properties of water. Water is one of the simplest natural compositions consisting of two atoms of hydrogen and one atom of oxygen. 42 combinations of these atoms are possible, 9 of them are stable. Thus, natural water consists of mixture of molecules with different properties. Oxygen of water has two pairs of electrons which don't participate in covalent bonds and able to create hydrogen bonds with other molecules. No, and now we should discuss the question due to some features of water. Water has high heat capacity. Biochemical processes in water medium cause in less amplitude of temperature and more constant velocity of reactions. In temperature 36-37 degrees Celsius, it has a maximum heat capacity. Water has high heat of vaporization. This property is used to support temperature homeostasis by sweat production. Water has high heat of melting. It decreases probability of cytoplasm and tissue fluid freezing in low surrounding temperature. And water is universal solvent for polar molecules, salts, alcohols, carbohydrates. It has a unique property to break almost all types of molecular and intermolecular bonds and form solutions. Now is physiological importance of water. Water is included into content of all biological tissues. Water makes approximately 60-70% of body weight. Loss of 20-22% of fluid causes death. Near 70% of water in organism is intracellular water. In extracellular water, 25%. In extracellular medium, 25% of water, and other 5% in vascular bed. These basic pools are exchanged with fluid. The entire fluid is filtered through kidneys 4 times a day. On this slide, you can see content of water in different tissues of organism, from minimal 0.2 in dental animal to maximal 99% in vitreous body. All tissues of our organism include water. A live cell needs water to store the structure and normal functions. Established that aging of organism is associated with loss of tissue property to fix water. Amount of water at old age is decreased. Water is a basic part of blood secretum, excrements of human organism. Water has a very important property to transport salts, microelements, and nutritive substances. Simultaneously, water participates in excretion of rests and toxins with sweat, urine, sputum. Water and dissolved substances, including mineral salts, provide internal medium of organism. Water is a mean of transporting substances inside of cells and in the extracellular space between organs and systems due to blood and lymph. The majority of chemical reactions take place in watery medium. In a lot of reactions, water participates as reagent. Such reactions as hydrolysis, hydration, dehydration. The main parameter of fluid medium of organism are osmotic pressure, pH, and volume. Homeostasis of intracellular medium is supposed by constancy of these parameters out of cells. The basic mechanism of self-regulation of osmotic pressure is associated with change of velocity of water excretion or sodium chloride excretion. Regulation of volume is provided by simultaneous excretion of water and sodium chloride. Regulation of pH is provided by selective excretion of watery solutions or acids and alkalines with urine. Disorders of water-salty homeostasis may cause swelling, dehydration of tissues, increase or decrease of blood pressure, acidosis or alkalosis. Now we should discuss hygienic functions of drinking water. In hygienic meaning, water is not simple chemical composition of hydrogen and oxygen. Natural water and prepared to feed drinking water as object of hygiene is complex physical, chemical, and biological system. The most of water is consumed by industry and agriculture, more than 90% of water taken from natural cycle. Drinking and household needs of population, municipal enterprises, hospitals, technological needs of food industry consume approximately 5–6% of common water consumption. From technical point of view, it's not a problem, but needs should be satisfied by water of certain quality, drinking water. And now you can see concept of drinking water. Drinking water, water in natural condition or after processing, variants of such processing, purification, decontamination, addition of deficient substances, responding to certain standards according to quality and assigning to drinking, household needs or production of meals. Rates of water consumption. Due to development of centralized system of water supply, one should know how much water is necessary for the population to satisfy their needs. Experience demonstrates that in presence of hot water supply, or using gas or electric boilers, 150-180 liters per day is enough for a person. Average rate of water consumption of cities of Europe is 300 liters per day in one person, including in-house 150 liters per person a day. Daily need in drinking water is 2-3 liters. Cooking needs 1.5 liters per day per person. In work in so-named hot shops, in hot climate, daily rate of drinking water increases to 10-11 liters. Water consumption is defined by a mechanism of thirst. Occurrence of thirst is connected with water electrolyte balance in organism and caused by osmotic pressure disorder. Feeling of thirst is a sure sign of water electrolyte misbalance with increasing of salt concentrations in tissues. Mechanism of self-regulation of osmotic pressure. Satisfaction of thirst testifies about restoration of homeostasis. Satisfaction of thirst is possible only by water with certain parameters of mineralization, adequate to internal medium of the organism. It's a physiological base of hygienic standardization of drinking water mineralization. Also, water is used for fitness, water pools, hydrotherapy, physiotherapeutic manipulations, going in for sports, spa aims. Besides providing physiological functions, water has the most hygienic importance as an index of sanitary safety of population. In contemporary conditions, water consumption is considered the index of country civilization. In 1980, in New York, at the special session of General Assembly of United Nations Organization, the General Secretary of the World Health Organization, Mahler, said, near 80% of all the diseases in developing countries are associated with unsatisfactory condition of water supply and inadequate sanitary conditions. Number of water taps per 1,000 population soon will become more demonstrating parameter of population health than a number of hospital beds. No, and now you can see such a slide where water as a factor of public health and where many factors, many features of water you can see. Water is factor of life supply. Water as index of sanitary safeness of populated areas. Factor of health support, and factor of risk of many diseases. And now I'll tell you examples of such feature of water as a reason, as factor of health state of population. In some cases, when drinking water is of poor quality, it can cause epidemics. The water factor is extremely important in the spread of acute intestinal infections, helminthic invasions, viral diseases, major tropical transmissible diseases. The main reservoir of pathogenic microorganisms, intestinal viruses, helminths, or in the environment. The main reservoir of these agents in environment is feces and household wastewater. as well as warm-blooded animals, cattle, poultry, and wild animals. Classic waterborne epidemics of infectious diseases are registered today mainly in countries with a low standard of living. However, in the economically developed countries of Europe and America, local epidemic outbreaks of intestinal infections are registered. Many infectious diseases, first of all cholera, can be transmitted through water. History has known 6 cholera pandemics. According to World Health Organization, in 1961-1962, the 7th cholera pandemic began, which reached its maximum by 1971. Its peculiarity is that it was caused by the cholera vibrio eltor, which survives for a long time in the environment. The spread of cholera in recent years is associated with a number of reasons. Imperfection of modern water supply systems, violations of international quarantine, increased migration of people, fast transportation of contaminated products and water by water and air transport, a widespread carrier of the Eltor strain. Next disease, typhoid fever. The waterway is especially characteristic for typhoid fever. Before the introduction of centralized water supplies, waterborne epidemics of typhoid fever were usual in cities of Europe and America. In less than 100 years, from 1845 to 1933, 124 waterborne outbreaks of typhoid fever have been described, 42 of them occurring in a centralized water supply. Today it has been next disease, dysentery. Dysentery, bacterial and endemic, amoebic, can also be transmitted through water. More recently, the problem of diseases caused by Legionella has arisen. Legionella are inhaled with aerosols and are second only to pneumococcus as a reason of pneumonia. More often they get infected in swimming pools or in resorts in places where thermal water are used by inhaling mist near fountains. Next problem, anthropozoonosis. A number of anthropozoonoses, in particular leptospirosis and tularemia, should be attributed to waterborne diseases. Leptospira have the ability to penetrate to intact skin, so a person becomes infected more often in swimming areas, in polluted water bodies, or during field work. Epidemic outbreaks occur in the summer-autumn period. The annual morbidity worldwide is 1%. During the recreational period, it rises to 3%. Waterborne outbreaks of tularemia occur when water supply sources, wells, streams, rivers are contaminated with the secretions of sea rodents during the period of tularemia epizootics. Diseases are more often among agricultural workers and pastoralists who consume water from polluted rivers and small streams. Although tularemia epidemics are also known when using tap water as a result of violations of the cleaning and disinfection regime. The waterway is also typical for brucellosis, anthrax, erysipeloid, tuberculosis, and other anthropozoonotic infections. Often, poor quality water can be a source of viral infections. This is facilitated by the high resistance of viruses in the environment. Today, waterborne outbreaks of viral infections have been more studied using the example of infections hepatitis. Most hepatitis outbreaks are associated with a decentralized water supply. However, in conditions of centralized water supply, water epidemics of hepatitis occur. For example, in Delhi in 1955-1956, 29,000 people. Hepatitis was revealed at such amount of people. And now we should discuss other diseases. Water also plays a role in the spread of helminthiasis, for example, ascariasis, schistosomiasis, dracunculosis, etc. Schistosomiasis is a disease in which helminths live in the venous system. Migration of this helminth to the liver and urinary bladder can cause severe disease. The helminth's larva can penetrate through intact skin. Infection occurs in rice fields and swimming in shallow polluted reservoirs. Distribution in Africa, the Middle East, Asia, Latin America. About 200 million people are sick every year. In the 20th century, it became widespread due to the construction of irrigation canals, stagnant water, favorable conditions for the development of mollusks. Next, helminthiasis dracunculosis, or Rishta. Other name of dracunculosis is Rishta. Helminthiasis occurring with damage of the skin and subcutaneous tissue with a pronounced allergic component. Infection occurs when drinking water containing crustaceans, cyclops, intermediate hosts of helminths. The disease has been eliminated in Russia, but it's widespread in Africa and India. In some areas of Ghana, the population is affected up to 40%. In Nigeria, up to 83%. The spread of dracunculosis in these countries is facilitated by a number of reasons. A special method of water intake from water sources with large fluctuations in water level. Which necessitates the installation of steps along the banks. A person is forced to go barefoot into the water to collect it. Next reason, ritual ablution. Religion prejudices that prohibit drinking well water. Water in wells is dark bad. In Nigeria, the custom of cooking food with raw water. The role of the water factor in the spreading transmissible diseases is indirect. Carriers, as a rule, multiply on the water surface. The most important transmissible diseases include malaria, the main four signs of which are registered on the African continent. Yellow fever is a viral disease carried by mosquitoes that breed in heavily polluted water bodies. Marshy areas. Sleeping sickness carried by some species of the special kind of fly tsetse, living in water bodies. Using contaminated water for wash face can spread diseases such as trachoma, transmitted by contact, but infection through water is also possible. Today in the world, about 500 million people suffer from trachoma. Next disease is Frambesia, a chronic cyclic infectious disease that is caused by agent from the spirochete group, Castellani treponema. The disease is characterized by a variety of disorders of the skin, mucous membranes, bones, joints. Frambesia is widespread in countries with humid tropical climate, Brazil, Colombia, Guatemala, Asian countries. Thus, there is a certain relationship between the morbidity and mortality of the population from intestinal infections and the provision of the population with good quality water. The level of water consumption primarily indicates the sanitary culture of the population. On this slide you can see documents regulating quality of water. In Russia we use two main documents. The Russian state standard water of sources of centralized water supply, and for drinking water, the Russian state standard drinking water. The first document, first state standard is used for sources of water supply, and the second one for drinking water. And such these requirements in this document are more strong. No, and in the world, international standards of drinking water is used. Hygienic demands to quality of drinking water include three groups of sciences. Water must have good organoleptic properties, harmless chemical composition, and must be epidemiologically safety. Water must be safe in epidemiological attitude. No, and the first group of parameters are organoleptic parameters of drinking water. Usually this checking these parameters don't require in special instruments, and where we check smell and taste. By state standards must be up to 2 points. Maximal scale include from 0 up to 5 points, but by standards must be not more than 2. If 1 it's normal, 2 points also normal. Next parameter, color of water. Special unit degree, up to 20 degree. It's usual water without any color. Transparency. It's transparency of water when through layer of water up to 30 centimeters we can read special text. Turbidity. Turbidity is presence of any mechanical substances in 1 liter of water. Must be not more than 1.5 milligrams. No, temperature of water, it's not very strong requirement, but for drinking of raw water must be certain temperature. If high temperature of water, it's usually such water is unpleasant for drinking. No, and now we should discuss many parameters of chemical composition of drinking water, because these parameters are very important. They provide organoleptic properties of water, they provide toxicological safety of water, no, and abnormal concentration of some of these substances may be reason of diseases. No, and first parameter, very important parameter, mineralization. Now we should discuss mineral or salt composition of water. Quantitatively, the value of the salt composition of water or the degree of water mineralization is determined by the value of the dry residue. No, dry rest or dry residue. The dry residue characterizes the sum of all chemical compounds, mineral and organic, dissolved in 1 liter of water. The amount of dry residue influences the taste of water. Fresh water is considered to have a salt content of not more than 1000 milligrams per liter. It's standard for mineralization up to 1000 milligrams in 1 liter. If the salt in the water is more than 2500 milligrams per liter or 2.5 grams per liter, such water is classified as salty. The value of the dry residue for drinking water should not exceed 1000 milligrams per liter. Sometimes it's allowed to drink water with a dry residue up to 1500 milligrams. Usually it's this parameter maybe for underground water, artesian water, because mineralization of such water usually more high. Water with a high salt content has an unpleasant salty or bitter taste. Pure natural waters, both surface and underground, are characterized by different salt content. As a rule, the value of this indicator varies greatly even within the same country and increases from north to south. Thus, in the northern regions of Russia, surface and groundwaters are slightly mineralized, up to 100 milligrams per liter. The main part of the mineral composition of water in these regions is made up of calcium and magnesium bicarbonates. In the southern region, surface and groundwaters are characterized by a much higher salt content and consequently a higher dry residue. Moreover, the main part of the salt composition of water in these areas is made up of chlorides and sulfates. There are the so-called chloride, sulfate, sodium water. There is one more indicator that characterizes the content of mineral components in water. This is the amount of water hardness. There are several types of hardness: general, removable, and permanent. The total hardness is the hardness due to the content of calcium and magnesium cations in the raw water. This is the hardness of the raw water. Removable hardness is hardness that is eliminated within 1 hour of boiling and is due to the presence of calcium and magnesium hydrocarbonates. Which decompose during boiling to form carbonates that precipitate. Constant hardness is the hardness of boiled water. It is most often caused by chloride and sulfate salts of calcium and magnesium. Magnesium sulfates and chlorides are especially difficult to remove from water. The value of the total hardness is normalized in drinking water, allowed up to 7 milligram equivalent per liter, sometimes up to 10 milligram equivalent per liter. This requirement is also for artesian water. For usual water, which we usually use, up to 7 milligram equivalent per liter. But in this slide you can see common hardness and different kinds of water. If hardness less than 3.5, it's soft water. Up to 7, medium. 7 to 14, hard water. And if more than 14, it's very hard water. Physiological significance of hardness salts. In recent years, the attribute to the physiological significance of hardness salts has radically changed in hygiene. For a long time, the value of water hardness was considered only in the household aspect. Hard water is not very suitable for industrial and domestic needs. Meat and vegetables are poorly boiled in it. It is difficult to use such water for personal hygiene purposes. Calcium and magnesium salts form insoluble compounds with the fatty acids of detergents, which irritate and dry out the skin. Water, both highly mineralized and low mineralized, can have adverse health effects. Water with a high degree of mineralization increases the hydrophilicity of tissues, reduces diuresis, promotes digestive disorders, as it inhibits all indicators of gastric secretory activity. Hard water has a laxative effect on the intestines, especially containing magnesium sulfate. In addition, in persons who have long-term use of highly mineralized water of sulfate calcium type, there are changes in water-salt metabolism, acid-alkaline balance. Hard water can contribute to kidney stones. On the globe, there are zones where urolithiasis is endemic. There are areas of the Arabian Peninsula, Madagascar, India, China, Central Asia. There are the so-called stone zones where there is an increased morbidity of urolithiasis. But there is another side to the problem. In connection with the use of desalinated seawater by the population, hygienic studies were carried out to standardize the lower limit of mineralization. Experimental data have confirmed that long-term consumption of distilled water or low mineralized water disorders the body's water-salt balance. Is based on increased release of sodium into the blood, which contributes to the redistribution of water between extracellular and intracellular fluids. Scientists believe that the consequence of these violations is an increased level of diseases of the cardiovascular system among the population of these regions. The lower limit of mineralization at which the homeostasis of the organism is maintained is a dry residue of 100 mg per liter. The optimal level of mineralization is a dry residue of 200-300 mg per liter. In this case, the minimum content of calcium must be at least 25 mg per liter. Magnesium not less than 10 mg per liter. Chloride salts are found in almost all water sources. Their content in water depends on the nature of the soil and increases from northwest to southeast. Chlorides impacts the taste of water, giving it a salty taste. The content of chlorides is allowed up to the limits of palatability, or not more than 350. In some cases, chlorides can be used as an indicator of contamination. Chlorides are excreted from the human body through the kidneys, therefore, household wastewater always contains a lot of chlorides. Sulfates, together with chlorides, are the main part of the salt composition of water. You can use water with a sulfate content of not more than 500 milligrams per liter. Like chlorides, sulfates are rated for their impact on the taste of water. They can also be considered in some cases as indicators of pollution. And now we should discuss occurrence of diseases associated with chemical or mineral composition of water. Diseases of non-infection etiology. More often, the entry of microelements into the human body occurs in this way. Soil, plants, animal organisms, man. For some microelements, for example, fluorine, other way is characteristic: soil, water, man, bypassing plants. Diseases associated with different levels of fluorine in drinking water. In natural water, the fluorine content varies considerably. The average daily physiological need for fluorine for an adult is 2,000–3,000 micrograms per day, and a person gets approximately 70% of it with water and only 30% with food. Fluorine has a small dose range from toxic to biologically beneficial. Fluorine is associated with the spread of two groups of massive and completely different diseases, hypo and hyperfluoroids. Long-term use of water, poor and fluoride salts, 0.5 mg per liter and less, develops a disease called dental caries. On this picture you can see example of dental caries. The morbidity of caries is unusually high. In regions poor in fluoride, almost the entire population is affected. There is an inverse relationship between the fluorine content in water and the prevalence of caries in the population. The fluorine content is below 0.5 mg per liter, the number of affected is almost 50%. Where the fluorine content approaches 1 mg per liter, the morbidity of caries is sharply reduced. There are several types of hypophtorosis. In intrauterine congenital accompanied by skeletal underdevelopment, more common in endemic areas. Next type, hypophtorosis of infants and early preschool children, is accompanied by delayed tissue growth rate rickets. Next type, hypophtorosis of school children, often manifested itself in the form of dental caries. And hypophtorosis of adults is accompanied by the phenomena of osteoporosis and osteomalacia. In special forms, hypothyroidism of pregnant women and postmenopausal women is isolated. During these periods of a woman's life, there is an active loss of minerals, which is accompanied by the development of osteoporosis. Senile hypothyroidism is distinguished into an independent group. However, excessive concentration of fluorine in drinking water lead to pathology also. Long-term use of water containing fluorine in concentration above 1.5 mg per liter contributes to the occurrence of fluorosis. And in this picture you can see dental fluorosis. Fluorosis is a very common geochemical endemic. Often the occurrence of this disease is associated with the use of water for drinking from underground horizons. In groundwater, fluorine is found in concentration up to 3-5 milligrams per liter, sometimes up to 27 milligrams and higher. For the first time, spotting of tooth animal as an early sign of fluorosis was discovered in 1901 by Egger among Italian immigrants. However, the link between fluorosis and increased fluorine content in drinking water was proven in 1931 only. For a long time, it was believed that fluorosis is expressed only by elective damage to the teeth and skeleton. On this picture you can see people with skeletal fluorosis. However, fluorine affects many organs and tissues. With prolonged consumption for 10-20 years, consumption of water with a fluorine concentration of 10 mg per liter and higher, changes in the osteoarticular apparatus can be observed. Osteosclerosis, diffuse osteoporosis, bone deposits on the ribs, skeletal deformation. Fluorine has an exceptional affinity for all calcified tissues and extra-tissue calcium deposits. Therefore, atherosclerotic vascular changes are often accompanied by local fluorine deposits. The same secondary fluorosis is often accompanied by cholelithiasis and urine lithiasis. The optimal level of fluorine for each settlement depends on the climatic conditions, the amount of water drunk, and therefore the amount of fluorine that is supplied forth into the human body primarily depends on the air temperature. Therefore, in the southern region, where a person drinks more water and therefore introduces more fluorine, its content in 1 liter is set at a lower level. At artificial fluorination of water, the fluorine concentration should be maintained at a level of 70-80% of the standards adopted for each climatic region. The most effective preventive measure against dental caries is water fluorination. Now we should discuss next problem associated with microelements. This disease is endemic goiter. The physiological significance of iodine is determined by its participation in the synthesis of the thyroid hormone thyroxine. Specific hormonal function of the thyroid gland is provided by the intake of iodine into the body from the outside, mainly with food as well as with water. Goiter is persistent enlargement of the thyroid gland caused by hyperplasia of the thyroid parenchyma, and is the most famous and widespread chemical endemic in Europe and America. Foci of endemic goiter are observed mainly in high mountainous areas in the entire of the interior of the continent. Some areas of the Alps, Himalayas, Carpathians, Pamir, Caucasus. Women are more prone to this disease than men, which is confirmed by statistics. In severe foci, women get sick 3 times more often than men. In the emergence of endemic goiter, a large role was assigned to the water factor, the lack of iodine in water. In reality, this is not entirely true. The daily requirement for iodine is 100-200 micrograms per day. The daily iodine balance consists of approximately 70 micrograms from plant foods, approximately 40 micrograms from animal food, and only 5-10 micrograms with water and 5 micrograms from the air. Thus, the body receives the physiologically necessary amounts of iodine not with drinking water, but with food. The low iodine content in drinking water is not a direct cause of the disease of the population with endemic goiter. However, a low concentration of iodine in water sources in a given area may have a signal value indicating unfavorable local environmental condition that can cause goiter endemic. The main preventive measures include addition of iodine to cooking salt. Next disease is nitrite methemoglobinemia. Until the 1950s, drinking water nitrates were considered as a sanitary indicator characterizing the end product of organic pollution mineralization. At present, nitrates of drinking water are considered as a toxicological factor. For the first time, the toxic role of nitrates in drinking water was suggested in 1945 by Professor Comley. Comley was the first to come to the conclusion that methemoglobinemia can be caused by drinking water with a high concentration of nitrates. With this message, the study of nitrates in drinking water as a factor in the morbidity of the population began. A healthy person always has a small amount of methemoglobin in the blood, 0.5 to 1.5%. This physiological methemoglobin plays a very important role in the body, binding toxic substances such as sulfides, as well as cyanide compounds formed in the course of metabolism. However, in a healthy adult person, the formed methemoglobin is constantly restored to hemoglobin by the enzyme methemoglobin reductase. Methemoglobinemia is a state of the body when the content of methemoglobin in the blood exceeds the norm, higher than 1.5%. Methemoglobin or hemoglobin is formed from hemoglobin as a result of true oxidation. In the gastrointestinal tract, nitrates even in its upper sections, are reduced by nitrate reducing microflora, in particular Bacillus subtilis, to nitrites. This process actively continues in the intestine under the influence of Escherichia coli Clostridium perfringens. Nitrite in the small intestine is absorbed into the blood, and here they react with hemoglobin. Excess nitrates are excreted through the kidneys. Children under 1 year old, nursing infants, are more sensitive to the action of nitrates in drinking water, provided they are artificially fed. Mixtures are prepared in water rich in nitrates. The lack of acidity in the gastric juice of newborns, physiological achillea, leads to the colonization of the upper gastrointestinal tract by nitrifying bacteria, which reduce nitrates to nitrites before they can be completely absorbed. In older children, gastric acidity inhibits the growth of nitrifying microflora. Another factor influencing the increased absorption of nitrites is damage of the intestinal mucous coat. An important role in the occurrence of methemoglobinemia is played by the presence of fetal hemoglobin in infants, which is much faster oxidized to methemoglobin than hemoglobin in adults. In addition, this is facilitated by a physiological feature of infancy, the absence of the enzyme methemoglobin reductase, which reduces methemoglobin to hemoglobin. And more or less of the hemoglobin of a sick child is converted into methemoglobin. Oxygen delivery to tissues is impaired, causing one or another degree of oxygen starvation. The level of methemoglobin exceeding 10% is critical for the body and causes a decrease of oxygenation of arterial and venous blood, a profound disturbance of internal respiration with accumulation of lactic acid, the appearance of cyanosis, tachycardia, psychic excitement followed by coma. On this slide, you can see parameters of organic pollution. These parameters are amount of dissolved oxygen, index of biochemical consumption of oxygen, oxidization of water, approximately rates for surface reservoirs 6-8 milligram per liter, for underground water sources and wells 4 milligrams per liter, for artesian water 1-2 milligrams per liter. Chemical consumption of oxygen, presence of organic carbon, approximately rates clean reservoirs 1-10 milligrams per liter, and for polluted 100 and more. Carbochloroform extract, if this parameter is 0.15, 0.16, reservoir is clean. 1 and more, reservoir is polluted. Determination of chlorides and sulfates. We discussed this question. Standard for these salts 350 and 500 milligrams. If content of these salts higher, it's also maybe parameters of organic pollution. Determination of nitrates. Here you can see two numbers, 45 milligrams per liter and 10 milligrams per liter. And usually we use this parameter, 10 milligrams per liter, by recalculation to pure nitrogen. Next group of parameters is very important. They are bacteriological parameters of drinking water, and usually at checking any water example, first of all we check organoleptic parameters and bacteriological parameters of drinking water. And here three main parameters: total microbial number, standard up to 100 in 1 milliliter, coli index, number of E. coli in 1 liter, up to 3, must be up to 3, and coli titer is amount of water which include 1 E. coli, which is standard for coli index 3, because in coli titer must be not less than 300 milliliters. And direct and indirect parameters of organic pollution of water. Direct high bacteriological parameters, which we discussed now, and presence of pathogenic microflora. And indirect parameters, change of organoleptic properties, rising chlorides, sulfates, nitrogen substances, and oxidation capacity of water. On previous slide you can see for nitrogen substances only nitrates may be in water. Nitrites and ammonia should be absent, and presence of these substances says about pollution of water, and we can estimate time of pollution. If ammonia and nitrites present in water, it's fresh pollution. If nitrates, it's old pollution. If all substances present in water, it says about continuous pollution, old and continuous pollution. Now, signs of epidemic with waterway transmission. We discussed many cases in the world associated with water. So water is a very important way for transmission of many diseases. And what are main signs of water transmitted spreaded diseases? Acute onset. Many cases of identical infections within first days. Territorial attachment of all cases to certain water source. Because if people take water from one water source, it also will be factor of water. It says about water as a reason of this outbreak. And rapid decrease of morbidity after disinfection of water source or forbidding its use. Now we should discuss questions due to kinds of water using. First of all is drinking. The most strict requirements to water according to the state standards. Household for supporting normal sanitary conditions of population life. Same requirements as for drinking water. Recreational, for rest, water sports requirements are less strict. Balneologic, for medical basis, inhalations requirements as for drinking water. Industrial, for using in the technological processes. special standards. Meliorative for irrigation in agriculture, special standards, and fishing for cultivation of fish and other hydrobiomes, special standards, and transport, because we have water transport. No, and now we should discuss question due to improvement of water quality. Very often we have water sources of not very good, not very high quality, because such water needs improvement. Now, all these methods may be shared into three groups: methods of water purification, methods of water disinfection, and special methods. What means water purification? It's free of water from any mechanical substances. And what parameters may be improved after purification? First of all, organoleptic parameters: color of water, taste, smell, transparency. No, the main methods of purification are settling. It's when water stay during certain time. Filtration with usage of special filters. And coagulation. Coagulation is chemical method. If settling and filtration are physical methods of purification, coagulation is chemical methods when some salts, usually the salts of iron or aluminium, added to the water. No, and control of sufficiency of these methods by water organoleptic parameters. Methods of water disinfection, very important methods, and they are maybe shared in two groups: physical and chemical methods. To physical methods we belong boiling, ultraviolet radiation, ultrasonic processing, and gamma radiation. Chemical methods are chlorination, ozonization, and usage of silver ions. Ozonization and processing by silver ions are very expensive methods because they are used very, very seldom. Ozonization may be used in some countries, but chlorination is the most frequent method of water disinfection. No, and for physical methods of water disinfection, also must be special conditions. Boiling also method which we used at home because small amount of water may be boiled, but for centralized water supply, this method is not good because it very high requirements in energy for boiling big amounts of water. Ultraviolet radiation also needs special appliances, special instruments for such processing. Ultrasonic also, and gamma radiation also, because these methods are used very seldom. Checking. How we check sufficiency of water disinfection? By water bacteriological parameters. I said you total microbial number, Colli index, Colli titer. And special methods of water quality improvement: deodorization, deionization, softening, desalting, fluorization, defluorization, denitrification, dechlorination. These methods are used also seldom because also special instruments are necessary for these methods. But in some places, in some countries, in certain places, maybe usage of these methods. For example, fluorination, opposite defluorination. These methods are very important, especially, now, in certain territories where low or opposite high concentration of fluorine in object of environment, first of all in water. And now we should discuss the most frequent and usual method of disinfection, water chlorination. What is mechanism of bactericidal activity? At addition of chlorine, it may be in gas form or chloride of lime in water, two acids formed, hydrochloric acid and hypochlorite acid. Dissociating later form cation ions of hydrogen, chlorine and hypochlorite ions. Well, this hypochlorite ion has the highest bacteriological effect, bactericidal effect. Scheme of chlorination. Chlorine requirement, its necessary amount of chlorine for disinfection of water. And how we can reveal amount of chlorine for certain water? By experimental way, because different kinds of water need in different amount of chlorine for disinfection. It depends on purity of water. Chlorine requirement consists of two parts, chlorine absorption and residual chlorine. Chlorine absorption, it's 90-95% of chlorine, full chlorine, connected with different substances in water. And residual of chlorine, it's chlorine which give bactericidal effect. Standard for this parameter 0.3-0.5 milligrams per liter. If we reveal number less than 0.3, it says about insufficient disinfection. If more than 0.5, it may be at very polluted water. It may be usually it may cause by high levels of chlorine at chlorination. And usually such amount provides specific chlorine, occurrence of specific chlorine taste and smell in water. So you should remember this standard 0.3-0.5 milligrams per liter. Maybe different kinds of water chlorination. Usual or normal chlorination, on chlorine consumption, chlorine requirement. Maybe double chlorination, when dose of chlorine is divided in two parts, 50-50, and added before and after water purification. Now it's considered such type the most effective. Double chlorination the most effective when disinfection together with purification. More high, more good results at such type of process. Superchlorination or hyperchlorination. Hyperchlorination it means addition of big doses of chlorine. In what cases it may be? Superchlorination is used in cases of very polluted water, if unknown water source, and usually in our conditions in Crimea we use superchlorination in summer period, in hot period, during summer. It will be it's prophylactic preventive measure against the outbreaks of infectional diseases. And last one kind of water chlorination is chlorination with preammonization. Preliminary addition of ammonia solution to water and formation of chloramine. This kind of chlorination is used for removing unpleasant smells in water. What are sources of water supply? There are four main kinds of water supply in the world: surface water, underground water, atmospheric, and desalting sea water. In our conditions in Russia and Ukraine, more often we use surface water from rivers, lakes, artificial water reservoirs, because the most easy type of taking such water, but surface water is one big negative feature. Usually such water is very polluted. Underground water may be shared into subgroups: subsoil water, water from wells, springs, and interlayer water, for example, artesian water. The subsoil water near the surface of ground and interlayer water more deeply underground. And all these types of water have different characteristics. Water from wells usually may be polluted, for example, polluted by nitrates. And people who use water from wells sometimes have problems, especially we discussed problems for babies. Artesian water, opposite very clean water, very good water, especially due to bacteriological parameters. Practical absence of any bacteria in deeply underground water, because such water is safe and cannot cause any infectional diseases. But artesian water usually has high mineralization, high amounts of salts of any minerals in such water may cause change of organoleptic properties of water. Atmospheric water, rains, water from rains, from snow, it's not stable sources of water, and because such sources not constant, and usually due to pollution of atmosphere, we cannot use such water for drinking. For some household conditions, we may be using atmospheric water, but not for drinking. No, and desalting sea and ocean water in the countries with high problems with water, where deficiency of water sources, maybe usage desalting sea water. But it's also very expensive way, because also needs special mechanisms, special big mechanisms, and also needs high amount of energy for function of such mechanisms. This is very expensive. Next question which you should know, zones of sanitary defense, sanitary protection of water reservoirs. Maybe 3 zones of sanitary protection, zone of strict regimen, zone of restrictions, and zone of observations. Zone of strict regimen, place of water pumping and main constructions of water system. Zone of restrictions, it's 5 kilometers from lake coast, some kilometers via the river, from the site of water pumping. And zone of observation, area of water consumption from certain water source. То есть zone of strict regimen is only place of water pumping and construction for water processing, special construction for water processing. It's a special zone, closed zone, and only people who work in this organization may come to this territory. It's zone of strict regimen. Zone of restrictions, it's certain territory around water source. Here must be absent of industrial objects and others sources of pollution. And zone of observation, and it's first of all epidemiological observations for population, for people, observations for people who use water from this water source. No, and now we should discuss ecological and hygienic problems of water reservoirs pollution. Main sources of water pollution are natural and anthropogenic. Floods, ice floating, corruption of biota, seasonal death of hydrobiomes. And anthropogenic sources are household sewage, industrial sewage, agricultural sewage, dumping of waste, water carriage, port works, nuclear power stations, and military polygons recreation. So all these sources are sources of water pollution. Ecological and hygienic consequences of pollution may be shared in. We say about hygienic consequences and ecological. Hygienic are restriction or impossibility of water using due to pollution. Deterioration of sanitary conditions of population life and disorder of health. It's very important. Disorder of health due to bad water quality. Accumulation of dangerous toxicants in fish. It also may be reason, and you know examples when accumulation of toxins in the fish may be reason of problems for health and population. And pollution of contact mediums. It's air, soil. Ecological consequences are reversible and irreversible changes of hydroecosystems. Drop of hydroecosystems productivity. Disappearance of important species of hydrobiomes. Reproduction of harmful and useless species. No, and basic now we should discuss question due to basic directions of water reservoirs protection. And here also we use our usual scheme for prophylaxis of any against any harmful factors, and because protection of water means measures against pollution or other reasons of change of water. No, and these measures include some groups: administrative, legislative measures, hygienic measures, where you should say about preliminary and current sanitary control, sanitary supervision. No, and first of all, when we say about preliminary sanitary supervision, we say about standardization of harmful substances in water. And here, first of all, criteria of harmfulness for three groups of parameters. Criteria of harmfulness, these criteria are used at hygienic standardization, organoleptic, changes of sanitary regimen, and toxicological. It's standardization for any substances in the water. We use three types of criteria of harmfulness. But we discussed near 80% of all standards are based on organoleptic criteria. Current sanitary control is control of water quality, searching sources of pollution. Next group of measures, medical preventive measures, searching population health independence on water quality. Architectural planning measures, zones of sanitary defense of water resources. Ecological measures, ecological monitoring of hydro ecosystems in association with pollution, and technological measures. It's a very important group of measures because at normal function these measures are effective. Self-contained technologies, absence of sewage, and changes in technology, drop of pollutants in sewage. No, and I finish the lecture. Be healthy. Goodbye. Завершить.